Hi again, guys. The second video here for lesson 10.2. In this one, we're going to actually work out the area of a hexagon, okay? This is a good problem to do. Hexagon is a good one in particular because it's simpler than kind of any other gon, like a septagon is going to be more work, octagon is going to be more work. Hexagon is going to be fairly simple, and you'll see why. So it's a good one to start with. And I hope you saw the prior video where we just explained the formula for area of a regular polygon. And we get, and I should have written it here, the formula, as you recall, is area equals 1/2 times the apothem times the perimeter, okay? Where the apothem, recall, is the perpendicular altitude, like height from the center to a side, okay? Which is going to be the midpoint of any side. Okay, that's the apothem. So essentially, you need to know the apothem and you need to know the perimeter. You just need to know those two things, okay? And it will always be enough information given to work out those two things. Before we begin here with a hexagon, I want to walk you through 3 bullet points right here. And you should write these down and just kind of keep these in mind when you're doing any one of these problems, okay? So the first thing you generally want to work out, okay? In fact, usually you have to, is the central angle, what's called the central angle, okay? And we're going to look at that in a second. Okay, and then from there, you can work out the apothem and the perimeter, okay? Maybe one of those things is given to you, okay? But you need to do all that, okay? Get the central angle and work out the apothem and the perimeter, and then you just plug into your formula and you're done, okay? Now let's talk about the central angle, okay? And for a hexagon, this is gonna be fairly simple. Let me erase a little bit here, okay? The central angle of a polygon is defined as the angle swept out by any 2 consecutive segments to 2 consecutive vertices, okay? So let's think about what that central angle is, okay? How would we get that central angle? Remember, the polygon is formed by this number of congruent triangles, okay? And that number of congruent triangles, of course, matches the number of sides, so hexagon 6, right? So that central angle is always calculated as 360 degrees divided by n sides. Hope that makes sense, right? So in a hexagon, n is 6, right? So 360 divided by n sides, 360 divided by 6 sides is going to be, of course, 60 degrees, okay? Now, this is why hexagons are kind of so beautiful, okay? Because essentially what you have there, if you have a 60-degree angle here, and you can also work out that the interior angles here are 120, which means that these are all 60. So you have equilateral triangles here in a hexagon, okay? So that makes hexagons particularly easy to work with. You have equilateral triangles all around, okay? So if you know that, for example, this is 10, you know that this side here is also 10, okay? But again, we're looking for the apothem, okay? We're looking for the apothem, all right? So hope you're with me on that so far. We work out the central angle, and then let's explore this triangle. So what I'm gonna do next is I'm gonna erase the large hexagon and really blow up that kind of central triangle, okay? So let's just blow up that central triangle, okay? With, again, remember this being our apothem, okay? Knowing that this is 10, and of course knowing too that this is 10, this whole side length here, okay? Because we have 60-degree angles, okay, all around. It's an equilateral, equiangular equilateral triangle, right? Okay. How are we going to work out that apothem? Well, if you've got 60 degrees up here as your central angle, and this is a 90-degree angle here, right? Well, half of this right here is what? Is 30, right? So, and down here is 60, right? So we have a 30, 60, 90 triangle, right? This half of that equilateral triangle is, of course, a 30, 60, 90 triangle. So if this is 10, this is 10, this little guy here is 5. Does that make sense? Short leg is half the hypotenuse. And our apothem, here we go, this is the all-important number, is going to be 5√3, right? The apothem is 5√3. So let's kind of like go through what we figured out. The central angle was 60 degrees, okay? That lets us ascertain that our apothem, working out through 30, 60, 90-degree magic, the apothem was 5√3, right? And then our perimeter, we worked out. Let me erase this a little bit, get room, okay? Our perimeter, I think you can figure that out easily enough, right? If each side is 10, the perimeter is 60, right? So all you've got to do now is plug into your formula. So 1/2 times the apothem times the perimeter, okay? And I'll let you plug that in yourself, okay? 1/2 of 5√3 of 60 is going to be 150√3. So I believe that should be the answer to your problem, okay? Right? you should end up getting that the area is 150 root 3 square units. And then of course you can punch that in on a calculator and round to whatever you need to round to. Okay, hope that helps. Thanks, take care.